So the chain rule can also be used to give a formulaic way to do implicit derivatives. So we won't do a computational example of this in a video, but what we will do is show you how to find the formulas. Or, well, show you what the formulas are, really. So let's set this up in the most general way. So we're going to say, suppose z is implicitly defined by x and y via the function, that's not how you spell the, via the function f of x, y, z equals 0. Right? And what we want to do is we want to find the partial derivatives of z with respect to x and y. Well, the chain rule can really help us do this without too much effort, actually. So we have up top the function f. All right? F depends on three things: x, y, and z. Well, z depends on x and y, whereas x and y, of course, don't depend on anything. They're independent variables here. Z is the dependent variable. So what we really want is dz dx and dz dy. Well, we can use this to solve for it. All right, so how do we do that, you might ask? Well, it's pretty much the same principle we did in the earlier video when we were computing the implicit derivatives. Right? So we want to take the derivative of this equation here. So how do we take the derivative of f? Right, so let's start by saying, let's do d dx of this equation. Right? This is essentially exactly what we did last time. Right? Well, we're finding df dx. Right? And the chain rule tells us, well, the first thing is df dx. And this time, I'll just write this as f sub x. Right? Now, the difference here between taking the derivative up here and over here is when we're doing it using this, the sort of dependency tree here, at this level, we forget that z depends on x and y. In fact, we forget about that until we get down to this area. So for now, z is just a constant as far as x is concerned here. All right. Well, the next x is down here, so we have to do the derivative of f with respect to z, and then times dz dx. And then, of course, the derivative of 0 is 0. All right. And so we can see pretty easily here that dz dx is going to be negative fx divided by fz. And, well, that's really it for that story. So if you want dz dx, all you really have to do is take the derivative of this with respect to x, then with respect to z, take the quotient and do the negative. Okay? Similarly, we can find dz dy is just negative fy over fz. Right? It's pretty much exactly the same story, except here's a y and here's a y. All right? So if you really want a formula for finding implicit derivatives, this is it. The chain rule gives it to us. And again, we've already done some examples of finding an implicit derivative. And I think the way in the earlier videos is actually better than memorizing formulas. But do whatever works for you. But since this is so simple, we won't do an actual example.